Hello to the learners. Here is a video about scaling operation for boiler temperature process. This is going to be demonstrated in Simatic Manager and integrated with WinCC for monitoring the process. So let us start. First, we need to open the Simatic Manager. After opening, we need to create a new file. We go to File and click on New. Next, we need to give a name to the project, for example, boiler. Next, we click on OK. Next, we go to Insert, Station, and Simatic 300 Station. Double click on the Simatic 301, then Hardware. Go to Insert, Insert Object, and double click on Simatic 300 as we had chosen before. Then click on Rack 300 and then on Rail to get our rails. We can just extend this. The first rail, of course, is for power supply and the second is for the PLC. So in the second, we give a right click, insert object, and we use CPU 3152DP. Then we do double click on GES73152AF02. Then in the subnet we do new and give a name to the new subnet, for example boiler network. Next, we give the comment, for example it is for temperature of the boiler. Then we click on OK, and we can see the boiler network name, and then we can click on OK again. We get the DP master system of boiler network. Next, we need an input output in the fourth rung. So right click on the fourth, insert object. We go to Simatic 300 and SM300, and here we need an AI300 with an analog output, so it's SM331 RTD. So next we click on it, right click, go to edit symbols, okay. In the symbols we give a certain name, for example temperature 1, and we can else give it a boiler 1 and give a data type as integer. You can also write is that temperature for boiler 1, and for the second symbol it's the same as boiler 1, but here it's only boiler 2, the data type being integer again, and the comment being the temperature for boiler 2. Then we click on OK, then again right click on it for object properties. Here in the name, as we can see the RTD, that is the analog, we can go to the address and see it starts from the same number as 256, and inputs Here the measuring type needs to be changed to resistors, that is RT resistor with measuring range as PT 100 CL. We need to change each one of this. And it's all 50 Hertz frequency. Each resistor. Okay. Then we need to save and compile a program. After done, close it. Go back to the steps of the boiler and click on the hardware CPU 3152DP. Now right click on blocks, then go to insert new object, functions. There go to symbolic name and give name as temperature. Scaling. Give okay. Go to FC1. Go to blocks. Insert new object. Go to data block. Then symbolic name. Data for boiler. Okay. The database data boiler 1 has been saved. Double click on it. Extend this. Rename dbvr as potence 1 and the type I change it to right click complex type array and give 0 double dot 10, that is from 0 to 10. Then we can give it as boolean and what 2, the data typing word array 0 to 10. Here we need to give word potence 3 array 0 double dot 10. Here we need integer potence 4. Right click on it, complex type array 0 to 10. Here we need to take real for scaling. So this is done for boolean, word, integer and real. Next we go to view, go to data view, and here we can see that each type, that is boolean, word, integer and real, has been expanded as per the arrays, that is 0 to 10. Boolean, word, integer and real. Next we go to view and go to declaration view. We can minimize this, and in FC1 we can double click it. Here our rungs are present. First, let's give a title to our first network, that is to start and stop the latch. So we'll write start, stop latch. Here I'll use a memory as switches and even an output. we are taking a latch memory, same as the output. So it's M0.0, M0.1 and M0.2, the output coil, which has the latch of same name M0.2. Next, we need to add a rung. Right click, insert network. Here the name is scaling operation. We insert an M0.2. Then we need to go to library and standard library, and then we need to use T1S7 converting block. Here we need a scaling converter, which is FC105 scale converter. Drag it. Here we need an input. For that, we first need to go back to Simatic manager, then go to CPU 315 or go to Simatic 301, double click on hardware. We go to the RTD, right click, go to object properties, addresses. See, the address starts from 256 and click on OK. Then we go back to our ladder program and write there PIW256. PIW is for analog input address for boiler 1. We are only using this for one boiler right now. Next, we need to give high and low limit. For that, we need to go back, go to Windows, go to data for boiler, go to view and data view. Here we'll go to real values. The first number is 46. Here we need to give maximum, that is 100.0, then 50 and 54 is the output. Then we need to save it. So first we will take 46, then 50 and 54. We go back, and the high limit we therefore give db1.dbt d db1.dbd46, and in the low limit we give db1.dbd50. In the bipolar we can give an input just to change the sign, I0.1. Now output. We need to go back, data of boiler. The number 54 can be used as our output. So we go back to temperature scaling, db1.dbd54, enter. Now the return value. So we stretch this environment interface, click on return. In the return value data type, we need to drop down it and go for word. Then go to Windows and data for this. As we can see, our first word starts with number 2. Therefore, go back to Windows and temperature scaling. You can write db1.dbw2, that's for word 2. And here we are, data for the boiler. So this is a complete program. Now we save it. Yes. We then go back to Simatic Manager, click on blocks, double click on OP1 and select STL. That's for scaling operation, and then click on OK. Now we can give this as a call function. So we write call space FC1, that is the temperature scale. When it asks for return value, we can give db1 dot dbw2. So this is the data for the boiler. We go back to Simatic Manager, we click all of this and click on download. But for this, we need to first virtually connect it. So click on simulation on. The sim view will appear. Click on stop. Then select OB1 FC1 FC105 DB1 and again download it. Click on OK. Yes. Go back to our ladder diagram. Click on download. Go to Windows and go back to data for boiler. Next, what we can do is download the ladder program again. Now we can simulate it and get to monitor it. Now in the sim view, we insert a bit memory. The PIW2256 needs to be written there, and then we can change the type to slider integer. This value is for mean value. I give 27684. We again insert a bit memory, and this time this is for the data of the boiler, that's the output. Here we can rename it as db1.dbt54. The output we have is in real, so now we can run it. But we need one more bit memory, that is after clicking on run. Now we go on for the first memory. By clicking it, we switch it on. Now our scaling operation has started. The temperature for boiler, we right click on it, reposition it as floating. And the data for boiler output, it's 0. The PIW 256, the slider. Now we'll change for the slider and see the output according to it. So as the slider increases, even the output increases and the output changes according to it. Now the output is 100. That's the maximum. Now if we slowly decrease it, even the output decreases simultaneously and relatively. Now we stop the process. We click on monitoring so that we can edit it again. Now we need to integrate the program with WinCC to monitor the process. So first we go to Simatic WinCC Flexible, open it, create an empty project. Then we go to multi-panels actually. 170 MP, 177 6-inch touch. In the left hand column we have device setting. Double click on it. You can see the start screen is screen 1. In the screen 1 in the left column, rename it by right clicking on it and write main. So start screen name is right now main. So we can give a name as boiler to it. Temperature monitoring, as we are going to monitor the temperature here. We can also choose MP277 8-inch touch depending upon the device that we have. Then in the main screen we need to go to project, integrate in step 7. Here we need to find a project here. The name was boiler, there it is. Double click on it. And in the right side tool column you can find text field. Now click on the blank space and you'll have your text ready to be written. Below is the text column. Now here I can give it as boiler temperature monitoring. Then go to properties. They will find the text color and background color. Change it as you want. Go to text and change the font. graphics, uh, let's go to enhance object and symbol library. In graphics, WinCC Flexible image folders, double click on it and you'll find miscellaneous symbol factory graphics. Double click on symbol factory graphics and you'll see different color fills. As for 16 colors, 2 colors and 256 colors. Go into the 256 colors and you'll find boilers. In the column just below to it you'll find boilers. Choose one needed. Next, go back to simple objects and input output field. Drag it to the screen. Double click on it and you'll find a column below. Click on the general, click on mode and click on output. Now in the process, go into tag, click on tags, click on boiler, click on Simatic 300, CPU 315, SN program, DB and open data for boiler. Click on war 1. Click on war 4 and click on the file that we had. Our file was dbd54, so we need to go to tag back, dbd54, there it is. Double click on it, give the format pattern as 999. Go to properties, then layout and change the position as needed in both X and Y axes. In styles, change as per accordance. Next, take another text field. Here we can name it as the C, just for the temperature purpose, that's it. Drag another text for the degree. This you can make it small. I need to manage the color as well. Make the size small as 8 or 10 as it is visible. This should be perfect. There we have the temperature in degrees Celsius. Now we need to go back to Simatic Manager, open boiler and WinCC Flexible RT. Open that and we'll see everything we have. So in WinCC we need to generate it. Start runtime system, click on it. Now we have a multi-panel touch. This shows 22 degrees Celsius already. Now we need to run it using SimView, and as per our slider, PIW256 slider, the temperature increases to maximum as predefined as 100. Thank you everyone.